21st. They're going with the 21st. Okay, why are we doing section 3.5 just after we finish section 1.5? Why are we going all the way to chapter 3? We talked about limits around asymptotes. So we looked at what does the limit approach when you approach some number, and those limits go to infinity or negative infinity. Now we're going to take that idea and turn it on its side. So we're going to look at what happens when x approaches infinity. What numerical value does it approach? Okay, so initially we did number gave us infinity. Now we're doing infinity is going to give us a number. This is really easy to do because all this is pre-calc. Okay, so limits at infinity, horizontal asymptotes. Remember how to find horizontal asymptotes? 3 cases. Okay, it's a good thing we're reviewing. Determine the infinite limits at infinity. Sometimes when you take the limit as x approaches infinity, your answer is also infinity. Yeah, you got that. Somebody else mentioned that. Davis wrap.
Yeah. Oh, if the bottom is heavy, keep it steady.
Yeah, I never knew that.
So
if the top is heavy,
if the top is heavy, just stop.
Just stop.
And then it's
There ain't no
0.
asymptote or something.
Yeah.
Yeah, we'll cover that minus the wrap portion.
I think we should bring back the wrap.
I think she should.
If she wants to come in and perform, we'd
Can
be
you
happy to
perform the
have.
wrap?
You don't want to hear me
I
rap.
think you do.
No, you don't. The only thing that would be worse is to watch me dance. And you should be able to converse in Pig
I
Latin.
can do that.
Can you?
Yes.
No. Can you? Can
Oh,
you
yeah.
do it together? Right now? Yeah.
Okay, ahead. It's hard, there's no first consonant. That's my defense. There's no first
Otway?
consonant. Uye one otway. I am a unday. If way or ye asse.
You lost me. Okay, let's look at this bizarre function. It looks harmless enough, 3x squared plus x squared over 1, or plus 1 I mean. But when you graph it, you get this weird little dip thing. So if we talk about what we've done already, let's suppose we take the limit as x approaches 0, we get a value of 0. That's easy because there are no holes, jumps, or asymptotes, vertical asymptotes. Then it's just going to be a straight up limit problem. But now we want to see what happens when we go very far to the right. What happens if I back way up over here? What y value is the function going to approach? 3. Are we all good on that?
Yeah.
What if I go very far to the left? 3. So in essence, all we need to do is find the horizontal asymptote, and the horizontal asymptote will represent the limit that we're looking for when we go very far away from the origin. Okay? Easy?
Sounds easy.
Oh, sure, it is easy. So let's review a little bit of precalculus here. Yeah, we talked about that already. Oh, look, increases without bound. Those terms show up again. You love those terms. And we get to case number 1. So this is pre-calc review. The degree of the numerator. How do you determine the degree of a function? Eric? Say again?
It's like the curve. No, it's not curved.
No, that's something different. We'll get to that later. Is that you talking now?
No, I think it was someone that there.
Rangi, was that you?
Power. Yeah.
Can you be more specific?
The highest power.
Like it's x squared on top and then x like 2.
So the degree of the numerator is 2, and the degree of the denominator. Why take the 3? Why not the power on the x over here, which is 0?
There's no like x on it.
There is an x. It's x to the 0. That's nerdalicious. The highest one. Thank you, Gabby. Yeah. So the degree is determined by the highest exponent in the function. So the degree of the top is 2. The degree of the bottom is 3. Very good. If the numerator is less than the denominator, then the horizontal asymptote is the x-axis. Is that in part of the wrap?
Yeah.
How's it
The
go?
bottom's heavy and the line is steady at y equals 0.
If the bottom is heavy, then the line is steady at the line y equals 0.
Not at the line,
No,
just at y equals 0. You're adding in too many words.
Oh, I'm
Yeah.
sorry. Like I said, I'm not
You need a big money symbol on your.
I do.
Yeah.
Or a clock.
Yeah.
Anybody?
Sorry.
A clock? Thank you. Flavor Flav, that's right.
Was it like a
Flavor
TV
Flav
show?
from the band originally.
What?
Wasn't it like his TV show Flavor of Love?
Yes, but he was in a incredibly influential hardcore.
The Beatles.
The Beatles, thank you. That's right. That's right. It was Paul McCartney, John Lennon, George Harrison, and Flavor Flav. It's not even funny, John.
It's like straight out of those people.
No, not.
Easy.
You sounded like such a white suburbanite. Was it those straight out of Compton, those people? That's NWA. No, he was in the other band of those people. Anybody? Not Wu-Tang. Good guess.
Public Enemy.
Wu-Tang came after.
Public Enemy.
Public Enemy is correct. Very good. How did we get to Public Enemy from here? Oh, did downside rap. Okay, great. Let's move on, shall we? All right, so we're good with this? Good. Second scenario. If the degree of the numerator matches the degree of the denominator, then you take the leading coefficients. The degree of the numerator here is squared, or 2. The degree of the denominator is 2. The leading coefficients is 3 over 2, and therefore my horizontal asymptote is at 3 over 2, or 1.5. And then the third scenario, is there a ref for this one, by the way?
I can't remember it. I'm just.
No, that's the next one. What, is there one for this one?
No, I think
It's
it's
not
just
important.
summarized.
Top matches bottom. What rhymes with bottom?
Bottom.
I'm sorry, did you say quantum? Salat. Okay, let's just move on.
I don't really what days. No.
I don't know what rhymes with the word bottom.
I don't make one.
Wait, it would be
Bottom,
two.
top.
Got him.
Got
That's
him.
not technically a word, right?
If the top matches the bottom,
You got one.
Then you already got
then you definitely got them. So then, yeah, let's
Freestyle.
yeah, just if this continues, we might need the dog. Third scenario is technically not a horizontal asymptote. It's called an oblique asymptote. I don't know why that's funny, but feel free. It's slanted, and we'll talk about these also. We're going to focus on case 1 and 2. So you get a true horizontal asymptote, because as your function gets very far away from the origin, either to the left or to the right, we get, I know you're writing this down, I'll come back. We get this little theorem. Okay, so the limit as you approach infinity or negative infinity is going to be the same as the value of the horizontal asymptote. Does that make sense?
Yes.
Good. Anybody not clear on that?
Can you repeat that?
As you get very far away from the origin, the value of the limit as you approach negative infinity or infinity is the same as the value of the horizontal asymptote. Alice, question?
No.
Just waving your hands in the air like you just don't care?
Wait.
Okay, back to the oblique so you can copy that down. So first step is to see which case you're in, case 1, case 2, or case 3. If you're in case 1 or 2, just find the horizontal asymptote. Whatever value you get for horizontal asymptote will also be the limit as x goes to infinity or negative infinity.
So what's the value for this one?
I'll get to that in a second. I want to make sure everybody's got 1 and 2 because that's more common than this one. Are we good?
No.
Maybe.
Okay. Kind of a gray area there, but. Does anybody remember how to find the oblique asymptote? Long division is correct. Guess what we're going to do next? No, we're not going to do long division. That's a waste of time. We're going to cheat. There's only one thing I need to know when working with an oblique asymptote. I need to know, is the slope positive or is the slope negative? In other words, graphically speaking, I need to know if the line goes like this or if it goes like this. Without doing long division, I don't really care what the actual formula or equation is for that line. I just want to know which way it's slanted. How do I do that? How do I determine the slope of that asymptote? No? Chickened out. You don't even want to guess?
Maybe plug in a high positive value for x and see if you get a positive or negative value.
You could, but there's a better way to approach it. If I was to divide out this to actually find the asymptote, I would take x cubed divided by 2x squared minus 1, correct? What is a positive divided by a positive? Positive. So the first term there, regardless of what it is going to be positive in this case. And that first term represents the slope of that asymptote. So just look at the leading coefficients and see if it's positive or negative. If it's positive, like this case, what's the limit as x approaches infinity for this picture? As x goes very far to the right, what's the y value doing?
Increasing.
Increasing to what point?
Positive infinity.
Correct. Increases without bounds, so that would be infinity. What if you go to the left? The limit as x approaches negative infinity of that line. Negative infinity, okay? So if you can figure out the slope of the oblique asymptote, you can find the limits as you go to infinity and negative infinity. That's pretty easy. I would just draw, it's positive, it goes this way. Okay, if I go that way, I keep going up and up and up. It's positive infinity. If I go this way, it goes down, 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 negative infinity. We don't do a lot of these, and I'm almost never going to expect you to figure out what the actual equation of the line is. I'm just going to ask you to find the limit there. And the first two are even easier because you just got to find the horizontal asymptote. We did that already. We talked about that. Okay, I've got a couple examples that I'm going to work through, and I'm going to solve each of these examples different ways, just to show you mainly what's expected mathematically and or what's expected practically. Okay, so I'll leave this one to you. What do you think that limit is? Or how do you find that limit?
Is it squeeze through?
Ooh, no, but a good guess. Any ideas?
Make it into one fraction.
Okay, we could do a common denominator there. We could do, let's see, that would be 5x squared minus 2 over x squared, and take the limit as x approaches infinity. Okay, which case are we in?
2.
Case 2, so where's the horizontal asymptote?
5.
Horizontal asymptote is at 5, so therefore the answer to the problem is 5. There's one way to do it. Good. Any ideas?
You just like plug in.
Wait, how do you get infinity from the bottom?
Oh, you want to plug in chug?
Depends if they're really small.
I like it. So if I plug infinity into that function, what's the limit as x approaches infinity of 5?
5 minus 5 minus 0.
No, just of 5. Yeah, I just want to know what's this. What's the limit as x approaches infinity of 5? 5, right. Why?
Because it's the thing you said before, the limits expression.
You're overthinking it.
This is no x, so it's just always going to be 5.
Yep. Or, what's the graph look like?
Straight line.
Well, all lines are straight.
Well, yeah, but a horizontal.
Horizontal line, so as you go very far, it's going to start at 5. Okay, that takes care of that part of it. What is this? So plug and chug. What do you get on the bottom?
A big,
What's infinity squared?
a bagillion.
A bagillion? It's a little more than a bagillion, but it's close.
Infinite bagillion.
Infinite bagillions. Also known as infinity. Good. So what happens when the denominator of a fraction gets very big and the numerator stays the same?
Small.
It gets really small. How small?
Really small.
Also known as 0. What's 5 minus?
No, but then.
Sure. If you have a fraction, so this is going to be 2 over something. If that denominator gets very, very big, then the entire fraction gets very, very small down to 0. Okay, so think about like 2 7ths, 2 10ths, 2 100ths, 2 1,000ths. It keeps getting tinier and tinier and tinier. It gets closer to 0.
How'd you do it this way?
This way. Degree on the top is 2. Degree on the bottom is 2. Degrees match. Leading coefficients 5/1. Done.
And that's the limit.
Correct.
Why are those coefficients the limit?
Because the horizontal asymptote is at 5. That's how you find the horizontal asymptote. Okay, question?
Is the limit of a horizontal asymptote always the same?
I hesitate to use always, but yes, most of the time it is. Okay, we okay? 2 different ways to do the same problem. You can do whatever method you want. I like the first one that we did better, but this also works. Okay, now if we look at this is all hold on, I get there you go. Yeah, we did that. Okay, yeah, okay, great. Okay, that's not. Yeah, we did that already. It's not very exciting. Yeah, that's 0. Okay. I want to get to this one. Where is it? Nope. Yep. Good. Yep. Great. Yep. There it is. All right. Part A. Let's do it the easy way. Let's do it the way we've been talking about for the last 20 minutes. What's the limit as x approaches infinity of that mess in part A? 3/4. Anybody have a problem with that? Numerator on the top has a degree. Numerator on the top, that's redundancy. The numerator has a degree of 2. The denominator has a degree of 2. Therefore, we look at the leading coefficients. The leading coefficients are 3/4. That means the horizontal asymptote is at 3/4. So therefore, the limit as you approach infinity is going to also be 3/4. Okay?
Yeah.
Mathematically speaking, though, from a pure mathematical approach, you should do it a different way. And you don't have to know how to do this, but I will show you just so I can say you've seen it. Where is it? Here we go.
Oh.
Let me explain what happened there. Right. I took the highest degree term and I divided everything by that same term. So the highest degree term was an x squared, and I divided everything by x squared. Is that a legal algebra move? Yes, because I wouldn't put it on a slide if it wasn't legally, algebraically legal, is what I meant to say. And notice what happens when you simplify things. Now we talk about the same thing that we just did on the previous problem. What happens when x goes to an infinity here?
It gets really small.
How small?
Like almost 0.
Or 0, right? So this goes to 0. What's that go to? 0. What's that go to? These 3 terms disappear. I'm left with 3/4. Done.
Oh.
Okay. The pre-calc approach is a little bit easier, I think. Yes?
Yes.
Good. We talked about that, 3/4. Okay, this one, let's go back to the slide so you can see the original problem. This one. What do you think?
3/2.
What's the degree of the numerator? 1. What's the degree of the denominator?
1. 2. 1.
What?
Square root.
2 or 1?
1.
It is 1. Because it's the square root of x squared. Make sense?
Yep.
So what we're seeing in this problem, when we start looking at these back terms here, they don't really matter at all. You can argue the same thing about this 1. It's not really going to affect anything. We want to look at this. So I can rewrite this as 2 times the square root of 2 times the square root of x, or sorry, try that again. I can write that as the square root of 2x squared, which would simplify to 2 times x. However, there's a little snafu which comes up right here. This is kind of an important concept that shows up. Chew on that for a second and see if it makes sense before I try to explain it to you. In fact, put in a negative number. Put in -2 for x. Do you understand why that minus sign is there now?
Yeah.
Okay. -2 squared is 4. Square root of 4 is 2. So I need the minus sign there to turn it back into a negative value. That pops up occasionally when you're looking at taking square roots of things squared. And I need that because when you solve the problem at the end, you get a negative answer. Okay. So it's what you thought it was. Using the pre-calc method, you thought it was 3 over the square root of 2. But what you have to recognize is that since we're talking about approaching negative infinity, you got to put a minus sign in front of it because the numbers you're dealing with are negative. It's a small persnickety point and not the end of the world, but still something from a purist standpoint is worth talking about. Question?
So that's when it's rooted? That's when
Negative infinity. Yeah, we started with negative. If it was positive infinity, it would just be 3 over root 2.
So if you came out with a negative answer for the limit of the negative infinity, do you make it positive? That was the standard.
Yes, you have to stick a minus sign in front of your answer.
Okay.
So if the answer turned out to be negative, you take the opposite of
Okay.
negative. There's a picture, like anybody cares, and last shot, and that is an infinity. What's A? Infinity. Anybody got a problem with that? Plug and chug. What about B? Negative infinity. Negative infinity. What if those are x squareds instead? Both be positive. Okay, good. Those are just plug and chugs. Okay, and again, you can think of it graphically also. What happens when you go very far away, it continues to go up. That's kind of the same thing we get with the oblique asymptotes. Going further to the right means the graph continues to go up, and eventually we get that value of infinity. All done. All right, we good? Now, the hard thing is going to be when you throw all these in the mix, keeping everything squared away.